Welcome all of you. In this chapter, we are going to see the factors affecting availability of potassium in soil. There are a lot of factors affecting internal factors, external factors. Among that, internal factors are very important. That what all the factors are affecting the availability of potassium in the soil, we will see. What are the factors affecting availability of potassium in soil? There are different factors, a lot of internal factors like soil pH. Under acidic condition, available potassium is reduced due to effect of iron and aluminum ion on root. Because the iron and aluminum are dominant in acid soil, since they are positive ions, it will compete with this potassium ion. So the lowest pH soil or acid soil is always unfavorable for potassium. Next, parent material, the feldspar. Wherever the feldspar is present, the availability of potassium is also very higher. Cation exchange capacity. If there is more CEC, high potassium availability or high potassium exchangeability, and texture, fine texture soil like a clay soil held more exchangeable potassium, whereas sandy soil has very lowest amount of potassium. Amount of exchangeable K, if initial exchangeable K is high, then higher potassium uptake is noticed in crops. Soil moisture, high soil moisture, greater diffusion means dissolving of potassium and higher availability of potassium is also taking place. Soil aeration, aeration should be optimum or good. Otherwise, the poor aeration will lead to the unavailability of potassium or lower absorption of potassium. Soil temperature, soil temperature also should optimum. Lower soil temperature always lower the availability. Presence of calcium, magnesium. Already we discussed about it. The calcium and magnesium is a positive charged ion which will compete with the potassium present in the soil. Then capacity to fix potassium. The soil rich in micaceous mineral will have more potassium fixation capacity, so that the mica rich mineral always supply higher amount of potassium to the crops. Factors influencing exchangeable K. What all the factors are influencing? Different factors are there here. One is wetting and drying, means presence and absence of water, which leads to the increase, which govern the increase and decreasing of nutrient, and potassium fixation also governed by this wetting and drying, and potassium release can occur by the wetting and drying. So how the exchangeable potassium is increasing or decreasing when soil is dry? Once the soil is dry, the potassium availability also get reduced. It is also depending upon the clay minerals present. What kind of clay mineral? 2:1 type of clay mineral or 1:1 type one type of clay mineral. And fixation. If the soil has high exchangeable potassium uh, and recent potassium fertilizer is added, or dried. And fixation is a result of potassium becoming trapped within clay sheets. I have told you that this is the layer silicate sheets. Between these layer silicates, they will be entrapped. Okay. And when it become very dry and uh, brittle like nature, the potassium fixation will occur. When the potassium release will occur, then soil low in exchangeable potassium or dried condition, the clay sheets roll back and release potassium. They will roll back and release the potassium. During the time, potassium release can occur. You can see clearly the potassium fixation. So this is elite. Elite is a potassium rich mineral and non-expanding type. This layer silicate, the layer silicates will not expand from their structure. Expansion means the increasing the size in the upper and the lower side because of the pressure creating inside. So here you can see the potassium is present everywhere, interlayer space and surfaces everywhere because potassium rich mineral. But at the same time, you can see vermiculite. Vermiculite is a expanding type of clay mineral expanding type of clay mineral, they will expand their structure. They are having potassium in their interlayer. During the dry period, it will lock very very tightly, but at the same time, when it is get absorbed by in the water or swelling in nature, the potassium may be released outside, okay, in vermiculite. Here, the same example, illite is non-expanding, so that they are very closely attached. Okay, showing very close, like this is interlayer space, this is outer space. So where the minerals are locked up. But in the Montmorillonite, this is expanding type of clay mineral. When the layers are getting expanded, the minerals are looking very free, so it can comes out anytime. But in the kyolinite, it is a non-expanding type of clay mineral where you cannot find any kind of minerals locked in between the layers. They always present in the surfaces of the clay sheets. Okay. How the potassium is releasing from the exchangeable and non-exchangeable. Okay, so this is exchangeable potassium, this is non-exchangeable potassium. The exchangeable potassium, they are having the potassium on the surfaces, means absorption on the surfaces. Okay, so once the equilibrium is happening between the soil solution and exchangeable potassium, the potassium is go to the soil solution immediately, because the rapid equilibrium is taking place. Equilibrium nothing but the presence of the potassium in equal amount both in the soil solution as well as the exchangeable sites of potassium. Once the potassium is getting absorbed by the plant, here the potassium depletion will take place. To compensate this potassium depletion, the exchangeable potassium will come and replace the losses. Okay, this is what the equilibrium. This process happening in very fast manner. But at the same time, this is non-exchangeable potassium, where the potassium not easily comes to the soil solution. One ion has to be replaced, the potassium ion, like a calcium. Once the calcium is entered inside, it will find a place here, and the potassium has to comes out, so thereby the potassium is coming into the soil solution. Okay, this is non-exchangeable potassium. Slowly it will come and become a exchangeable one, right? So Page and Weber in 1940, they have uh, they have told a lattice fold theory. The potassium size, ionic size of potassium is very close to the lattice hole. Lattice hole, nothing but a layer will be there. In that layer, there will be a hole where the potassium will be locked up. Okay. The potassium ionic size as well as the hole present in the layer silicate size also very similar, so that the potassium can come and easily sit on the hole. That theory was given by Paver and Badge. This theory is known as lattice hole theory. This is lattice. In this lattice, there is a hole. So where potassium is trapped. This theory is called lattice hole theory. So the intensity of potassium fixation is zero with kyolinite, because it is not expanding type. Fixation will not happen. In the previous slide also we have seen, in between there is no ions. Okay, no potassium, only they are present on the surfaces. Okay, chlorite also in the same way. The chlorite 2:1:1 type of clay mineral, where it is a non-expanding type, and slight with montmorillonite, variable with illite, and strong with vermiculite. Okay, vermiculite is a partially expanding type. This vermiculite also we have discussed in earlier, and the montmorillonite is a highly expanding, so that slight fixation will take place. Okay, but variable with illite and strong with vermiculite. Okay, so this is happening because of cation exchange capacity. Cation exchange capacity also varies with the clay minerals, so that the potassium fixation also will get vary here. What are all the factors affecting potassium fixation? One is type of clay mineral. What type? We have seen that kyolinite non-expanding and vermiculite is partially expanding and montmorillonite is highly expanding. So depending on the type of clay mineral, the potassium fixation is taking place. Similarly, alternate wetting and drying, freezing and thawing. This also we have discussed in previous slide. When the potassium is releasing, when the fixation is happening during the wetting and the drying time. And soil pH. Here also we have seen the iron and aluminum will compete with potassium, or else the iron and aluminum keep potassium ion from close association with colloidal surfaces, means in the clay surfaces. Okay, so uh, which will make the potassium is not absorbed by the colloids, but they are always absorbed ions of iron and aluminum, which will keep the potassium very closer to this. It will prevent the absorption. Okay, but when you are applying the lime nothing but a calcium carbonate, which will be applied to the acid soil. Once the lime is applied, the iron and aluminum activity will be reduced. Okay, so potassium move closer to the colloidal system and it will get fixed. Okay, this is what happening in soil pH. Okay, so the iron and aluminum is hinders the fixation between the colloids and potassium. Once the aluminum and ion are removed from the soil by applying lime, the potassium is fixed on the colloidal surfaces. What are the losses of potassium? There are four losses. Crop removal. This is must be happen, and leaching, erosion, and soil fixation. These are all the four important loss. The erosion is very minimal here because the potassium is less mobile nutrient in the soil. Sometimes if there is any flood and all happen in the soil, the erosion may take place. Leaching also very small here. Okay, but the soil fixation also another problem depending on the soil pH condition. The leaching losses of potassium, they are largely observed in sandy soil because sandy soil has less nutrient holding capacity, so leaching is happen. But in the clay soil, the leaching is very minimal. In humid tropics, leaching the major factor limiting in productivity, means in the high rainfall zone where the leaching is a biggest problem, which will limiting the productivity because of the losses of potassium. The potassium source also influence the leaching loss. Okay, uh, what kind of sulfate based or chloride based or different potassium sources also. Compared with the potassium chloride, that is muriate of potash, the sulfate and phosphate sources exhibit greater anion absorption. Hence, leaching loss is low. Okay, sulfate and phosphate sources, potassium sulfate and potassium phosphate. Okay, they are anion absorption. Their absorption is very high, so that the losses are very less. Crop removal. Crop removal is very high potassium or high amount of potassium will be removed here, like 3 to 4 times of that phosphorus and equaling that of nitrogen. Almost equal amount of nitrogen and 3 to 4 times of phosphorus is absorbed by the crops. Okay, in terms of potassium. Sometimes the losses of potassium is made more critical when plant take up for excess of its requirement. Sometimes what will happen, the potassium is being uptaken continuously by the plant. Okay, more than the required amount. So this process is called luxury consumption. This luxuriously, the potassium is continuously taking up by the crops. Okay, so this luxury consumption is only associated with the potassium. Okay, luxury consumption. Coming to intensity and quantity ratio, means the power of soil to supply potassium to plant roots is described in terms of intensity and quantity. What is the power of soil there? How the potassium supply is maintained by intensity and quantity factor. If you see, the intensity factor is a measure of the potassium that is immediately available to the root, immediately available to the root. Okay. And the quantity factor is capacity of soil to manage the level of potassium in soil. How much level of potassium is maintained in the soil? How much potassium is immediately available to the crops? Okay. How much potassium is maintained is called quantity. Quantity of potassium is maintained. And the potassium is how much potassium is readily available to the plants. So this ratio between these factors is called quantity and intensity. This is quantity, how much potassium is managed, then intensity, how much potassium is readily available to the plants. So this potassium also is uh, relate with the calcium and magnesium, since we have seen the reason earlier. They are positive charge, so that this also will affect the potassium ratio here. And buffering capacity, it is also very important. It is also depending on the quantity and the intensity ratio for buffering capacity of potassium K plus ion. So this concept of buffering capacity of soil indicate how the potassium level in the soil solution is varies with the amount of labile form in the element. So buffering, how the potassium is varying or maintaining in the soil is depending upon the intensity and the quantity. Okay, in soil solution and amount of labile forms in this element. Okay, labile form means it is readily available form. Okay, so this ratio will change when the quantity factor is changing and intensity quantity factor to the changes in intensity factor. Okay, their ratio also change. So this, if the ratio is very high, the soil has good buffering capacity. The same time, if has low ratio between qi, they are having very lowest buffering capacity. Okay, clay textured soil having more buffer capacity than sandy soil. Clay always having, because absorption is very high here. Okay, thank you so much.